Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Hello, everyone. Welcome to the live mock interview session. I'm just waiting for some more people to join in so that we can start as soon as possible. And I'm really very sorry for the delay today. And I thank all of you for waiting up. We will be just starting in another 1 minute. So I hope I'm audible to you and the video is clear as well. Yep, okay. Okay, cool. So, without further ado, let me introduce you to our in-house GFG mentor, Dhananjay, who has 4+ years of experience of competitive programming, and he himself is a software engineer at Geeks4Geeks with a code first rank of 1870. Next up, we have Susanka, who is an SD intern at Wecommit, and Dhananjay would be taking the interview of Susanka. So I will just quickly add them both to the stream. Hi,
Sandra.
how are you?
Hey, hi,
Hi.
Sandra.
Okay,
So,
so
how
I
are
have
you guys?
introduced both of you to our viewers, and
Okay.
now over to you, Dhananjay. You can go ahead and ask whatever you want.
Okay, sure. Thank you. Okay, thanks, Sandra. So, hi, Susanka. How are you? And how's everything going on due to this, this lockdown, pandemic, and all? Yeah. It's like I'm fine like currently, and like regarding the pandemic, it's a mixture of stress and like something like getting locked down in the house. And like other than that, everything is going fine. And how are everything with you? I'm good too with my side also. Okay. So
Okay.
yeah. So like okay. So can you brief me about yourself, about your college journey, and if you have done any interns or the projects that you have worked on, or your
Okay,
area
okay,
of
sure.
expertise also?
Okay.
Yep.
Hello, myself Susanka Majumber, and I'm currently a fourth year student at Jadavpur University, and like I'm majoring in computer science and engineering. So I'm currently also interning at Wecommit as an SD intern, and so some of my interests include web development, especially like full stack development, and as well as competitive programming. Yeah, that about my interest.
Okay. So as you said that you have done competitive programming. So on which platforms have you, done the contest and all that CP part?
Yeah, so I used to practice on Code Forces as well as CodeChef.
Okay. Nice. Okay. So yeah, I think that we are good to go. Okay. So before moving further, I would like to know that in which programming language you have expertise and how much you can rate yourself from a scale of 1 to 10 in DSA.
Okay, so I like mostly code in C++. Like if it is a DSA based question, and I would like rate myself an 8.
Cool, cool enough. Okay, so so we can move further. Like I have few questions on DSA for you. Okay, so
Okay,
my
sure.
first question to you is that you are given an array,
Okay,
right? And the size of this array is n. That means you have n integers.
okay.
Fine. Then the property of this array is that each element in this array, further before moving to the main question, the array consists of all the integers. That means negative as well, zero or positive. Cool.
Okay.
Now further, the array consists of all the duplicates number except one number which is not duplicate.
Okay. Okay.
So you have to find that single number which is occurring only once.
Okay. Sure. Sure.
Yeah.
Yeah. I think I got the question. Do I share my screen?
Yeah, sure. If you have some test cases to to let me know that whether
Okay.
you have any
Okay.
doubt or the question or not.
Okay. 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 Sure. Um, okay. Just a minute.
No issues. Take your time.
It's visible now?
Not till now. Yeah, now it's okay.
Okay. Sure. Uh, okay. So you said we will be given an array. Let's say -9, -7, 0, 6, 5, and then let's say again 5, 5, 6, 0, -7. Yeah.
Yeah,
So
yeah.
in this case, so everything will be duplicate except one element, like
That is
n.
-9.
Okay, -9. So we have to find the number that is not duplicate. Okay, yeah. So in that case, is there any like constraints to the elements, like up to what
You
range
can
the
consider the
elements
size
can?
of the array is 5 into 10 raised to the power 6. That is n is equal to 5 into 10
Yeah.
raised to the power 6.
Yes. Okay, size of the array and the like element themselves. Any the AI.
We can consider them 10 raised to the power 18.
Okay, sure. So in that case, we can actually have a map and hash map. So we will actually store the counter of each and every element in the hash map. And once we have stored the elements in the hash map, we actually go through the hash map once again and see what value have counter one, and this will be our answer.
Okay, so which map you will be using? Like, what is the time
Uh,
complexity of this one?
Okay, so if I use like a regular map, it would be it would be an O or like O of n log n approach, and if I
Okay,
use
wait a
an
second. Wait a second. You said the map will be at the time. If you implement with the normal map, the time complexity will be n log n. So
yeah,
can you explain why n log n?
just a minute. Uh, Yeah, because like a normal map actually stores them in a sorted order. So like in the sorted order, so in order to insert them, so like if we see like how the map is actually internally implemented. So if we actually so it is, I hope it is actually implemented with a binary search tree. So like during insertion, each operation actually will take an O of like a log n time, log of the current length of the like array. So it
Are you
would
sure?
be just a minute.
You said that the map internally is implemented with the help of a binary search tree. Are you sure that it is a binary search tree or something else?
Uh, yeah, I'm not like currently not sure.
So it is implemented by a binary search tree, but it is a special kind of binary search tree called as balanced binary search tree.
Okay, okay, okay. Yeah, yeah,
Cool. Balanced
yeah.
binary search tree. So now, can you tell me how come the time complexity is n log n for that entire map?
Okay.
What is n in this?
So n in actually is the length of the array. So
Mm-hmm.
like so if let's say we have actually inserted some like some element in the array up to some like let's say up to n-1. So when I actually insert the nth element, it can go anywhere. So in order to like then we actually apply the balance function in this. So the balance function actually tries to minimize the difference between its left and right child. So so since it have to minimize the left and right child, it actually has to traverse to the height of the tree,
Cool,
which
cool.
will so the maximum
Which will
height of
take
the tree
log
would be
n,
n log.
and for
Yeah, yeah,
n
log.
elements, it would be n log n. Okay,
Yeah,
cool.
yeah.
Yeah, so it is the time complexity, and what will be the space complexity?
Yeah, so space complexity would be O of log n actually, because I'm storing n elements only. So this would be the space complexity.
Okay. Okay, but in the worst case, it might. Okay, so you're considering log n. Can you explain why log n?
Uh,
Because the size of array is n, right?
no, no, no. I'm saying O of n. N. I said O of n. Order of n.
Okay, okay. I heard you said O of n log n. Okay, no issues.
No, no.
Okay, so can you do something better?
Okay. So since we will be given some an array, we can since all of them actually occurring an even number of times, specifically two here, so we can actually XOR all the elements.
Mm-hmm.
And so we know XOR is a cancelling operation, like XOR of two, if two equal number will be zero. So if we actually like take XOR of the entire array, so all the all the like duplicate element will cancel themselves up. So we will be left with the like non-duplicate element itself.
Cool, cool. Okay, so the time complexity would be what?
The time complexity in this case would be O of like O of n log n. We will actually take like a continuous XOR. Like we will actually initialize something. Let's say initialize a variable and actually take like go on XOR like every element of the array. So it would be
So it
O
would
of
be
n.
O. So that means
Yeah,
each
and
element will
space
be
complex.
traversed only once. Okay.
Yeah,
Okay.
yeah,
Now,
yeah.
if I twist this question, suppose the question says that the array is in a sorted form. It
Okay.
might be descending order or ascending order. Doesn't matter.
Okay.
But for simplicity, keep it in ascending order. Now, how will you implement it? Is there any other
Uh,
approach?
okay. So let me just think for a minute. -7. Yeah, it's -7, 7, 0,
Okay,
7.
so I will provide you a hint. For simplicity, just take the positive numbers only. Okay? No need to take the negative
Okay.
numbers.
Okay, sure, sure. 5. Okay. So it would be yeah, it would be sorted, and everything will be duplicate itself. Yeah.
Yeah, yep, yep.
Okay. Okay.
Except that
So
one
let
element
me,
which you have to find.
yeah. Okay, sure.
Okay. So in this case, the answer would be 5, right? The 5 is the
Yeah, yeah, yeah.
alone element.
The answer would be 5.
Okay.
So so let's say we will have, so we have to actually go to this element, right? Now if we have 3, so we can try to use a binary search, but we wouldn't know where actually the current element is. Oh, yeah.
So what's your, what's your idea in your head? Can you just let me know that what you're
Okay,
thinking?
okay. So I've been trying to use a sort of a binary tree, but so if I choose a middle element and then check with the left and right, we can be sure whether it's duplicate or not. But after that, I cannot decide whether to discard the left or like right half. So I think this wouldn't be a valid approach. But let's say. Hmm.
Just take your time. Okay. I'll provide you another hint. Just draw, just just map the indexes with all these numbers.
Okay, sure. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Right. Okay. Yeah. O of I. So 0 and 1 would be. Okay. Okay. Yeah. Yeah. We can do a binary search actually. We actually like we can see that here that, let's say if a of I and a of like a of sorry a of 2 to the 2x and a of
One
2x.
second, Susanka. Can you just maximize the screen of your Sublime one and just
Okay,
stop
okay,
splitting the screen?
okay, sure, sure, sure. It's,
No, no, no. Like
yeah, is it
the sub. Yeah, yeah, yeah. Now,
is it
now
better
it's
now?
better. Yeah, sure.
Okay, so we can see that so these two indexes will have same element. Sorry, yeah. So where x is an like where they are like valid index and x is an integer. So we what we can do is we can
Okay, wait a second.
actually
Wait a
like
second. You are saying that a, suppose if x is a valid index, right? So you are saying that suppose
uh,
2x, array of 2x and array of 2x plus 1 will be equal.
yeah, 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 yeah. So
You sure?
because here so except for the like except for yeah, no, like not for the duplicate part actually. uh, yeah, it wouldn't be, no, no, no. Yeah, so what we can do is, yeah, so we can do this approach like I actually so we use a binary search. I land on like I land on the middle point. Okay, and then I let's say I check its like leftmost element whether it is equal to this or not. Yeah, so if the leftmost element is equal, so we know that this is not the duplicate. So now I have to decide whether to discard the right or right or like left subarray. So
Okay.
what we can so if I have landed on this point and like up to this point all the numbers are actually yeah, since
Duplicate.
yeah, no, 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 like if this is an event index, if even index, because if like all the numbers are actually duplicate, so it will be a like double of some amount basically. So if this is, let's say, yeah, like odd index odd but an even position, so we can be sure that our required element won't be in this array, because if our required element were in this array, let's say it was one, then actually we would have gotten on a like in a even index basically. Am I able to explain the approach correctly?
Like
Okay,
I'm a bit of confused with the approach. So can you explain a bit better?
okay, okay. So so we can, so let's say I have this is the middle element, and I have checked it with the left index, and I know that this is a duplicate. So now up let's say I have landed on ith index right now. Sorry, mid. Let's say mid in the correct index. So like if mid isn't actually an even position, if mid is that is an odd index. So okay, sorry. If mid So if mid is an odd index, so so we can be sure that in the left subarray we won't find our like required element, because since up to the like left since this is a duplicate element, I know, and this is also an event index. And we only have one like duplicate element. So if it like if our required element were in this range, I wouldn't have landed in an odd index, because in this case, see, in this case what would have been the approach, uh, like
Okay, okay,
like
okay, okay. So as far as I can understand your approach, you are saying that you will first of all find the middle element
yeah,
as usual we do in a binary search. Then you will be
yeah, yeah,
checking with the left element,
yeah, yeah,
its adjacent left, whether it is equal to or not, and according
yeah.
to that you will be shifting to the left or right.
Yeah, yeah, yeah. So yeah, so so I will check the left element, and if the if this is a duplicate, if this is a duplicate, if I if I find
Okay,
that this is
first of
not
all,
a
okay,
duplicate.
okay. First of all, you modify the array, put a one again, right?
Okay,
Because yeah, now
yeah,
now you can explain.
okay, so let's say I have landed in the third position. Or yeah, so if this is a duplicate, this means that if it's like left child, not left, like left adjacent element is actually equal to this one. Okay, just I will just write this one actually. If a of mid equals a of mid minus 1. So yeah, so this means that left element is actually equal. um, so so in this case actually I will check whether whether mid is like odd or not.
Okay. Okay.
Okay, if mid is odd, I can absolutely like discard the left subarray. So
Okay.
in this
Okay.
case, because if odd is like sorry, if a mid is odd, this means I am at even position, and also I have found like a duplicate element at its like left adjacent element. So this means that our required answer cannot be in the left subarray.
Okay,
So
okay, okay.
in this,
Wait a second. Okay, just take it a baby steps one by one. Now I have understood that step in which you said that suppose if your mid is an odd index, and the left hand
yeah,
side that is the mid minus one is equal to array of mid. Fine.
yeah, yeah, yeah,
Now what
yeah.
happens if the array of mid is not equal to array of mid minus one? What will you do?
Yeah, so there will be like another check. I will also check this time. I will check like on the right side. Yeah, yeah, this time I will also check in the right side. uh,
No, no. Wait a
like
second.
if
You said that first of all you will check whether the index is mid or not. That is equal to odd or not. Mid
yeah,
index.
yeah, yeah, yeah,
And if it is an odd index, then you will check whether it is a whether array of mid is equal to array of mid minus one or not.
yeah. So let me just write the pseudocode.
No, no, no.
If
I got your idea. Just revert it back. Just revert it back. Right. So after line number 7, if array of
Yeah,
mid equal to array of mid minus one, then you will be
yeah,
incrementing your low with mid plus one. Now that might also
yeah,
happen that right that your array of mid, even if the index is odd, then your array of mid is not equal to array of mid minus one. Then what will you do?
yeah. So in like if yeah, I'm like telling the approach. The I will check this one. Okay, so in this case this will happen, and then I will also if this doesn't happen, let's say like mid of mid minus 1 is not actually mid of mid plus 1, then I will check the like right adjacent element. Okay, so if let's say if the right adjacent element is also the adjacent element like is the duplicate one, then we will check that whether n minus mid is like odd or not, basically. So yeah, like the
Do you don't you
let's say
think that don't you think that first of all you have to check whether the index is even or odd or not? Then after you can decide whether array of mid minus one is equal to mid or not, right?
so
Because I don't think
okay
that it would work.
yeah, yeah, okay, let me just say it in another format. Okay, so if I have landed in a mid, I will and I have found found that the duplicate actually lies in its left, if the
Uh-huh.
duplicate exists at all. So I will check whether up to mid whether the subarray that is one up to mid is the size of the subarray is even or not. Is this clear now?
Yeah, yeah, yeah.
That is, if I have landed on this 3, and I have checked this that this 3 is also equals to this one, then I will check up to mid whether the size of this whole subarray is even or not.
Okay, so basically you're saying that suppose if you're at it mid and it is an odd element, then you're saying that if it is an odd element, then its duplicate would occur on the just left side if the array is
Yeah,
perfectly fine on the left hand side, right?
yeah, yeah, yeah.
Okay.
So yeah, exactly. So if the element if the whole element is even, I can be sure that only the our answer will be contained on only in the right subarray.
That's correct. Okay. Now what if the
Th-
array, if you're at odd index and your array of mid is not equal to array of mid minus one, then what?
yeah, then I will also check this one, that whether array of mid equals array of so I will now check for duplicate in the left index. So let's say I am in the third position,
No,
uh,
no, no. But
and
like as you said that if the duplicate occurs on the left hand side, then you're sure that your left hand side that is from zero to mid is perfectly fine.
yeah, yeah,
That means you're incrementing your low to the right side. That is low equal to mid plus one.
yeah,
Now
yeah,
what
yeah.
if?
So now I will search in this one. But what
Yeah.
if so yeah, so you said that what if that this was like not 3, right?
Yeah.
Yeah,
Yeah.
yeah, kind of like this one. let's say like for the sake of this example, let's say we have, yeah, so let's say we have something like this
No,
one,
no.
then
Do
I
one thing.
have,
Do one thing. Delete a five
okay,
from it. Delete a five from it.
yeah,
Delete it.
5
And
5, and I will do this with 1.
no, no, no. Yeah, yeah, yeah. Do this.
Yeah, okay, so yeah, as I was saying, yeah, if this doesn't happen, let's say the like left array is not perfect, like perfectly normal actually. um yeah, so yeah, so another thing is, if this is like even, if this is even, then I will discard the left subarray. But if this is odd, then I can be sure that our answer will lie in the like left subarray itself.
Okay. Okay.
So else I will be like, this will be r of mid minus 1. And okay, so this is the case that if this is like,
Is this
if
case
the
right?
duplicate,
Is this case right? The condition is
uh,
written. The sixth line will come above the fifth one, or the fifth will come above the sixth one. Because you're
sixth line,
shifting. Because you're shifting on the condition of what? On the basis of what? That whether your index is odd or not, or that is the index is odd or even.
yeah, 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 yeah. So would it change the answer? Yeah, sorry, I can do like, if,
No, like on what basis you're checking whether the left one is right or the right one is right? If it is odd, then you're
yeah,
checking
yeah,
on the left index, right? As you would check on
yeah, yeah, yeah,
the right index. So
yeah.
this sixth line should come above the fifth line, not below it.
This one.
This
No,
only sixth condition. The mid.
no. I'm saying, no. If this will only apply if the like, if the duplicate of this element is found in the left array itself. Let's say for some, like for some array, I have landed in an array where let's say this is the mid. Okay, now the duplicate will be in the right adjacent element. Let's say like. Uh, let's say this, like let's say this one itself actually. So I would have actually so if this is 9, I no, sorry, 10, yeah,
Trust me, Susanka. This approach would not work because the condition on what basis you are deciding whether to go left or right should be the main condition. So that's why
okay,
it can't be a nested
okay,
condition for that. Okay, so sixth would come above it.
okay,
Okay, on the basis of whether it is the just left adjacent element is equal to the another one or not. On that basis, you
yeah,
will
yeah,
shift to that one.
okay, okay, yeah. So if actually like, if we, then we don't find like the, so if let's say if the left element is not duplicate, then we check in the like right element whether this is duplicate or not. So if this is duplicate, then we also like, then we shift this thing in the left subarray actually. So
So
yeah,
how would you shift in the left subarray? What will be the condition for that?
yeah, if,
No,
if,
why to if? Why if? Because if you're
sorry,
saying
sorry,
that
sorry.
array of mid is equal to, then else should be coming, right?
Yeah, yeah, yeah. So this would be a of mid plus 1, considering that this is a valid
Why
index.
this? Why this? Why do you need to check this? First of all, listen it, right? You're checking for that odd index. If you're currently standing at odd index, then you're
Yeah,
checking whether the left adjacent element is equal to that mid or not,
yes, yes, yes,
right? And with it, and
yeah,
if it is equal, then you're shifting to the right hand side.
yeah,
Fine.
okay, okay, yeah,
And else, if it is not that, then you're by self saying that that you will shift to the left hand side, right? The left part. Then
yeah,
how will you shift to the
yeah.
left part?
So the I will just shift the like right index,
Okay.
like the right pointer. And like if we don't find the duplicate in any of this, then we know that this is our answer actually, like a of mid.
Is that all?
I cannot think of any other approach right now.
Okay. What if you're at odd you're at even index. That might happen that you're
Okay.
at even index, right? And this
Okay. Yeah.
condition won't satisfy.
Uh, yeah. So we have to check for like another even index as well. So on the basis of, let's say, so this is up to this part is fine. So let's say, like, now on the basis of, let's say, even index. Let's say, now if like, let's say I'm on an
Okay, okay. Wait a
even
second.
index.
Wait a second. Wait a second. In the 10th line you written, else if both the conditions are not met, the answer will be equal to met. Do you think that in
Yeah.
any of the condition, in any of the case, will this line be fetched or reached? Is there any
So
third case? Is there really any third case apart from that array of mid equal to mid minus one and array of mid not equal to mid minus one? Will there be any other case? So this line won't mean that
no,
thing,
no, no,
right?
no, no,
So
right.
th-
Hmm.
just delete
Yeah.
this 10th
This.
entire line. Just delete 10th entire line because there is no logic for that. Okay. Now,
Okay.
just tell me how would you fetch it if you're currently your mid is at an even index.
Okay. So like, let's say I'm at an even index. Let's say 6. So yeah. So let's say 6. And in this case, what will happen is I will again check the like left and right subarray. So in this case, let's say I know that this is not equal. Like, this is not that its duplicate is not in the right like left subarray. But so in this case, yeah. But this its duplicate is in the right subarray. So if this is in the right subarray, uh, that is if a of mid equals, sorry, that is if a of mid equals a of mid plus 1. So I will now like I will now discard the left half. That is, I will again do this, l equals mid plus 1. And else I will do this, like r equals, sorry, yeah. So now I check in the like right subarray. If this is equals, if like this duplicate lies in the right subarray, then I will discard the right half. That is, r will become this time mid minus 1.
Okay.
So yeah, this will be the solution.
Okay.
uh,
Okay. 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 So okay. Now, what is the condition in which you will be finding the answer? You are not getting any answer out of this.
yeah. So right. Mm. So if I, like, let's say if I actually don't find like if I actually don't find like index, like duplicate in element in any of this, then we will just directly get the answer.
Are
So
you sure? Okay, just tell me. Are you finding a duplicate element from this entire code, or just finding the index at which you can find? What are you trying to do with this code?
yeah, so I'm trying to, like, trying to actually discard the left half and right half based on the
That's right.
condition.
That's right. That's right. But what, like, what on what thing are you traversing? Are you traversing on the answer or the indexes?
I'm traversing on the indices. So like,
So
so I'm checking for duplicacy here. And
okay.
let's say I don't find the duplicacy here, and I'm also checking for the like duplicacy here. And I actually checked exhaustively that whether I can find the duplicacy in left or right subarray or not. So if I
Wait a
can't
second.
find
Are you finding the duplicacy or the occurrence of an element which is only occurring once? What are you trying to find?
uh, I'm trying to find the duplicacy because the equality condition is here.
Are you
So
sure?
if
On what basis are you shifting your binary search or search space? On the basis that, okay, just tell me on what basis are you shifting your binary search?
I'm shifting my binary search tree on the basis that whether duplicate lies in the left or right subtree. Yeah.
Right. But like you
No,
are
sorry.
shifting to find the answer, uh, but you're shifting in the
In
left and right side to find whether that single element will be on the left hand side or the right hand side, right? So by
Yeah, yeah,
this
exactly.
only, by this entire piece of code, you are only shifting to the left or right part.
Yeah, yeah,
But
yeah.
where are you trying to find the answer?
Yeah. So just a minute. I will think. Yeah. So if I okay. So at the end, I will be left with only subarray of one element, right? Yeah. So yeah. So at the end, basically, I will be left with only subarray of an array of a range of one element. So this element would be our answer actually. So after I have actually traversed through all the list, so where this will terminate, our answer will be at a of l, that sorry, a of l.
Okay. Why won't A of H? It is A of I.
um,
Are you
yeah
able to imagine or visualize when the binary search is completed? Where are your low and high pointers are pointing?
okay,
Whenever a binary search is completed.
just a minute. So for now, let's say this is l.
No, no,
Okay,
no, 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 no.
I
It's
will
just a
just
simple. No, no,
I
no.
will just
That's what I'm saying. That's what
drag.
I'm saying. There is no need to try on this. It is a simple logical question. Okay. You just visualize the part. Like when the binary search is completed, where are your low and higher pointing?
uh,
When this loop
so
will be over.
so the loop will be over when actually there is only one element left. Now the
Right.
question is, yeah. Now the question is, like
If there is one
where,
element, then but if there is
yeah,
only single element, then where will be a lower high?
yeah, it will be the same point actually.
Then the answer would be also A of high also, right?
Yeah,
Not
yeah, yeah,
necessarily A of L,
yeah,
right?
yeah,
Okay,
yeah,
so
yeah,
that was
exactly.
this question. Okay.
Okay.
Now, okay, so I'm done with the DSA part. Let's come on to some basic C++ approaches. Okay. So, what
Okay.
do you understand by OOPS?
So, object-oriented programming is a paradigm of programming. In which we try to modularize a code. So we actually try to make some entity based on a real world, and we assign some variables and method associated with that entity, and like try to group together all similar functionalities and all methods and variables in a class. So we basically
Okay.
do that in groups.
Okay. So, have you heard of the concept of data abstraction or abstract class in C++ OOPS?
Yeah, so data abstraction is basically we try to hide some details from the programmer, and we actually only sort of provide with something that is that the developer needs to know. So for instance,
Okay.
let's say I'm
Yeah, yeah.
okay,
Go on,
let's
go
say
on.
for instance, let's say I am actually internally implementing a segmentary. So if but we don't need to know how to do how the range update is going internally. We can provide the left and right range, and a range for, and a value to let's say do the range update. So we actually hide the actual implementation from the programmer.
So, how do you do it?
Yeah, so we can actually put them in let's say different packages, so the programmer won't be able to access it. We
Packages. Like, what's the
Yeah,
keyword for how do you just abstract the code or
so
the segment you
we
want
we
to,
can
you're trying to,
we,
yeah, go
yeah,
on.
we can use access modifiers such as private and protected
Okay.
variables.
Okay. Okay. Now, since you have discussed about data abstraction, you must have also heard about the abstract classes.
Yeah, but yeah.
Okay. So, what are the abstract, like, how do you define an abstract class?
Okay, so abstract classes like so sort of is sort of something that 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 like that don't have an implementation provided within itself. So like if we consider a real world analogy, we would say like an abstraction is something like we are provided with the interfaces, but we will have to like have like its child classes to actually implement the phases. So let's say we have a student abstract class, and we also have some child classes like CAC student, ECE student, and other student. So like in a real world implementation, we will actually, so the student don't exist actually. It's like an like something so if there is any student, it have to be assigned to any department. A student without any department doesn't exist. So this is what is meant by extra class. We actually don't like provide the implementation itself, we just provide the interfaces. Or let's say
Okay.
in case.
Okay.
Okay.
Okay. No, no. Okay. Okay. I got it. So, can you explain me or just tell me one use of that virtual keyword?
Yeah, so like the virtual keyword can be used to, like, let's say, define virtual methods. So what virtual method does is we actually provide some function at the base, like at the base class, and then we actually override those functions um, in the child class itself. Now if we use, let's say, an object of the base class, which is but a reference to that child class, so it will actually invoke the function that is defined in the child class and not in the base class. So we can use that to do like use
Okay.
so like
So,
create virtual function.
have you heard of the diamond problem?
uh no, actually.
Okay. Okay, no issues. So yeah, Sanka, like I'm done with my side. Okay. So is there any question from your side to me? Like you want to ask anything?
No, actually.
Okay. Okay. So like, okay, so we are done with the interview. So it's time to give you a feedback. Okay. So as far
Okay,
as
sure.
I just analyzed your this entire interview, as far as I can sort of give a feedback is that everything that you have mentioned in a resume, okay, you need to prove that
Okay, okay.
everything that you have mentioned in a resume should be like you should be like suppose if and for an instance everything that you have mentioned in a resume, if you're sleeping at night and if any guy wakes you up and asks you anything that you have mentioned in your resume, then you should be able to explain him at that point only, because
Okay,
everything you write in a resume should be there. So as I have seen your resume, you have mentioned you have done CP and all the other stuff, DS and C++, right? But like as I've asked you this binary search question, it is a very the binary search technique or the binary search concept is a very classic and a standard approach. But you should know the internal working of binary search, right?
yeah,
Because
yeah,
as I asked you that what suppose if a binary search is ended, then where are your low and higher pointing to, right?
yeah,
So
yeah,
for that you don't need to do the dry run of that entire code. Just be knowing by
yeah,
heart if you have literally learned that binary search concept. Apart from that, the oops concept are very very much important, and you should be, because
yes.
everyone knows the bookish definition of this oops concept. But then how are you able to differentiate yourself from any other candidate if I talk only in terms of oops concept? So you should be telling us the concept with the help of real life examples that you
Okay,
did with the
okay,
help of
sure.
abstract classes, but you should be telling it in such a manner that the interview should be impressed or convinced with your answer.
Okay,
uh,
okay.
with this concept in mind, or I have a follow up advice for you also, that just try to just try a way so that you can explain your approach to the interviewer well. Because as I judged
Okay,
that you were not able to completely try to explain the idea that was in your head. The idea that you might be having, it may be wrong, it may be right, but I'm not worried about that wrong or right idea. I'm worried about how do you try to explain me, or how are you able to get or catch my hints that I'm providing to you. Fine.
okay, okay,
So on that stuff you need to literally work on yourself. Okay.
okay, sure.
Okay, so that's from my side. So I guess Sidra can join and just open up this session.
Yeah. I hope, Susanka, you're convinced with the kind of interview that happened, and I hope
Oh,
it really helped you a lot in
yeah,
every
yeah.
possible manner. And thanks a lot,
Yes.
Dhananjay, for taking out
Nice.
a lot of time for this interview session. And for the viewers, I'm hoping that you're going away with a lot of key takeaways, and this is going to be really helpful for you as well. So, thank you everybody for joining in, and a very good luck, Sushanka, for the interview whenever, wherever. We hope
Okay,
all the
sure.
best and we wish you all the best.
Okay, sure. Thank you.
Thank you, guys. See you soon
Thank
again. Bye.
you. Bye bye. Take care.
Bye.
Bye.
Okay, so guys, this was the live mock interview session with our in-house GFG mentor and one student who is interning at Wecommit. So I hope you guys enjoyed it and it was helpful. See you again next time soon. Till then, stay safe, get vaccinated, and stay geeky. Bye bye.